Hey folks, in this video this is a problem from the homework, the one with the peanut M&Ms. Let's get to it. So we are told some various probabilities or proportions of the population of peanut M&Ms that follow a certain color. And so we're going to use these to answer our questions below. The first question asks that what is the probability that a randomly selected peanut M&M is not orange? Well, we are also told that 23% of them are orange. So we want to use the property of complements there to determine this. We would simply say 1 minus 0.23 is the chance of getting a peanut M&M that is not orange, so 0.77. The main idea there is the property of using complements. With the next question, we are looking for the probability that a M&M is yellow or blue. And since the word "or" is showing up, I'm going to get ready to utilize the addition rule, where we want to consider, can we have a M&M that is yellow and blue at the same time? No, right? These are mutually exclusive. So we would just get the probability for the individual events, yellow, blue, and add them up. So we're told there's a 15% chance for yellow, and blue is also 23%, so that should do it there. Cool. For these two parts, this was for a single M&M. For the next question, it is assuming there are two M&Ms being chosen. And here we want the probability that both are yellow. Since 15% are yellow, and assuming that the two M&Ms selected are independent, then we can just square that quantity. Here, the main property being used is independence. And I'll open up a calculator. 0.15 squared, 0.0225. And it does say to round to 3 decimal places, so I'll go 0.023. Now we've got 6 M&Ms. Now we're talking. Compute the probability that none are orange. Well, we can use some of our previous work here because in part A, we found the probability that the M&M is not orange. We know that that's 0.77, but that's only for one M&M. This needs to apply to 6 M&Ms. So just like in the previous part, we can raise this to the 6th power under the assumption that, again, each M&M is independent. Each M&M independent. And let's take that to our calculator. Rounding to the 3rd decimal place, 0.208. Last but not least, we have 6 M&Ms again, but this time compute the probability that at least one is orange. At least one is orange. Okay, this one can potentially be considered kind of tricky, but if you know the trick, it is not bad at all. It is possible to get 0 M&Ms that are orange. You can get 1 M&M that's orange, or 2, or 3, or 4, or 5, or 6. Okay. That would be part of the sample space there for number of oranges. And if there was a probability for all of these, wouldn't they have to add up to 1? Okay. If we had all the probabilities listed there, they have to add to 1. And we want at least 1 being orange. Okay, so we need to consider the part that I'm circling in blue. That's the probability we really want right there in blue, which would be all the probabilities except the 0 being orange, right? That was all the blue probabilities there except no oranges. And so to calculate this, we're going to use complements again, where we want all the probabilities except the probability of no orange out of 6 M&Ms. And boy howdy, look, we've already computed that up here. So this is going to be 1 minus 0.208, which is 0.792. Let's go type these in and see how we did. I've got all my answers boxed, so that makes it really easy to just cruise along here. Oh, a whole swath of green check marks. That's very satisfying. Good job, y'all. See you in the next video.